All right, in this video, we're going to go over partial fraction decomposition. And partial fraction decomposition is basically the reverse procedure of adding two rational expressions together. So you start with a rational expression, and then you want to write it as the sum or difference of simpler fractions. And this is something that's going to be super useful and necessary later on in calculus. Now, before you begin partial fraction decomposition, you want to make sure that your rational expression is proper, meaning that the degree of the numerator is less than the degree of the denominator. If it's not, then you go ahead, long divide, like we've discussed before, and then you can proceed with partial fraction decomposition on the remainder from that long division. And I have a video on polynomial long division if you need a reminder on how to do that. Okay, so there's four main cases when you're doing partial fraction decomposition, and I'm going to go through an example of each case. Okay, so the first one is Q, which is the denominator factored, has only non-repeated linear factors. So each of the factors of the denominator are unique, and they're all linear, meaning they're all raised to the first power. Okay. So in this case, the partial fraction decomposition of P over Q is going to be of the form A1 over x minus A1 plus capital A2 over x minus A2 all the way up to AN over x minus little a sub n, where the numbers A1, A2, etc. are to be determined. That's what you're going to solve for. I usually use A's and B's or ABC instead of subscripts on the A's, but it's up to you. So here, first example, find the partial fraction decomposition of x over x squared minus 5x plus 6. So the first step is you need to factor the denominator here. So it's going to factor into x minus 3 times x minus 2. And notice each of those factors are distinct and they're linear. They're to the first power. So I'm going to set up my partial fraction decomposition, and it's going to have the form a over x minus 3 plus b over x minus 2. Now it's my job to solve for a and b here. What's the first step? Well, the first step is I want to multiply the entire equation by the LCD by x minus 3 times x minus 2 to clear out all the fractions. Okay, so now on the left-hand side, I'm just going to have x left over. And then on the right-hand side, when I distribute this to a over x minus 3 is going to cancel. So I'm going to have a times x minus 2 plus, notice here I'm going to have b times x minus 3. Okay? Now from here, there's two different ways that you can solve, and I'm going to show you both because you're going to need to know how to use both depending on which case you're in. So for this case, we could use either method, but for other cases, you're going to need to use one in particular. All right, so here we go. So method one, you choose a value for x that will make the factor equal 0. So I'm going to let x equal 2. And then now notice what happens. So if I'm letting x equal 2, then on the left-hand side, that's going to be a 2. Equals a times 0, so that'll just be gone, plus b times 2 minus 3. So this is going to be 2 equals 0 plus b times negative 1, which means b equals negative 2. And then similarly, if you want to solve for a, all you would do is substitute in what would make the other factor x minus 3, 0. So you would let x equal 3. And then 3 would equal a times 3 minus 2 plus b times 0. 3 minus 2 is 1, so then we get a equals 3. And then when you write out your final answer, you always want to write it out that you have the original rational expression. So let's see, where was it? It was x over x squared minus 5x plus 6 equals, now a was over x minus 3, so I have 3 over x minus 3 minus, or you could put plus negative 2 over x minus 2. Okay, good. Make sure you write out what the actual decomposition are, what the partial fractions are, because someone else may have set it up so that A and B were interchanged, but your end result, your decomposition will be the same, okay? Now, what about the other method? You will need it for other examples, so let's learn it now. So method 2, we're going to go back to this step here that I boxed, okay, after we cleared out the fractions, after multiplying out by the LCD. So what you do here is you're going to actually distribute everything all the way out. So I'm going to have x equals ax minus 2a plus bx minus 3b. And the idea here is we use the fact that since there's a 1x on the left-hand side, right, the coefficient of the linear term is 1, then that means all of the coefficients of x on the right-hand side, namely a plus b, must equal 1. So you're grouping them together. You're basically saying x equals ax plus bx, but right now I'm not interested in solving for x, right, so I could factor it out. And really what I want to know is, well, what values of a and b satisfy the equation that a plus b is equal to 1, okay? You can skip writing this step if you can just look at it and tell. Then notice here, negative 2a and negative 3b are constants, right? They're not attached to any variables. And what is the value of the constant on the left-hand side? Well, I don't see one, so it's 0. So also 0 is equal to negative 2a minus 3b. And now we're in a situation where we have a system of two equations with two variables. Here's equation 1, here's equation 2, and I can solve this system however I want. I'll just do elimination. I'm going to multiply this equation here by 2. So now I have 2 equals 2a plus 2b. Add them together, so a is going to cancel out. Then I have 2 equals negative b, which means that b is equal to negative 2, which is what we got using the first method. And then back into equation 1, if I substitute negative 2 in there, so into equation 1, I have 1 equals a minus 2, so a equals 3. And then I could write out the partial fraction decomposition, and it would be the same thing as above. Okay, so it's up to you, whichever method you want to use on this particular case, case 1, where you have non-repeated linear factors, but for other cases, you're going to have to use one method versus another, and you'll see why in just a second. Okay, good. Now, case 2. Q, the denominator, has repeated linear factors. So if the polynomial q in the denominator has a repeated linear factor, so you have x minus a raised to the n, and n is greater than or equal to 2, then the partial fraction has to have the following format. You start off by listing x minus a to the first power, then to the second power in the denominator, and you work your way all the way up to whatever that highest power is that you see in the denominator. And then in the numerator, you're going to have all of the constants that you're going to find. Okay. So notice here, the following example, we have find the partial fraction decomposition of x cubed minus 8 over x squared times x minus 1 cubed. Now, x squared is a repeated linear factor. It's x minus 0 raised to the second power. And then x minus 1 cubed is also a repeated linear factor. So I'm going to have 5 partial fractions in this case. Does that make sense? Watch, I'm going to set it up right now. So we have x cubed minus 8 over x squared times x minus 1 cubed. And so I'll start working on x squared. You have to start listing it to the first power. So I'm going to have a over x to the first plus b over x squared. And that's the highest power that I see in the denominator in q of x, so I'm done. Plus, now let's move on to x minus 1. So I need c over x minus 1 to the first plus d over x minus 1 squared plus e over x minus 1 cubed. And now I stop because that was the highest exponent that I saw in the denominator, and this was the highest one that I saw there. But you have to have everything below it starting from 1 all the way up, okay? So the first step is always the same. You're going to multiply by the LCD. Now be careful that you identify it correctly so that your problem doesn't turn into a nightmare. So the LCD is going to be x squared times x minus 1 cubed. Okay. Now on the left-hand side, we're just going to have x cubed minus 8. And that's going to equal, now when I distribute this to a over x, one of the x's is going to cancel out. So I'll have ax, x minus 1 cubed, plus the next one's going to be b times x minus 1 cubed. The x squares cancel. Plus, then I have cx squared times x minus 1 squared, plus dx squared times x minus 1, plus ex squared. Okay? That should have been an x squared. Okay, now look here. How many coefficients do we have to solve for? We have to solve for 5 of them, a, b, c, d, e. For sure, you do not want to do the second method I showed you of multiplying everything out. It will turn crazy. So what we do is we're going to start off substituting in values of x that will make a lot of things cancel out or equal 0. So the first thing I'm going to do is let x equal 0, because all of these terms will go away. So if I let x equal 0, on the left-hand side, I'm going to have 0 minus 8 equals, so this is going to be a 0, plus b times 0 minus 1 cubed, plus, this is just going to be a 0 now, dx squared, that's going to be a 0, and ex squared is a 0. So what do I have here? Well, now I have negative 8 is equal to b times negative 1. So that means b is equal to 8. Okay, that's good. That's 1 down. We've got 4 to go. So now what else should we let x equal? Well, I want to let x equal 1 because the other factor is x minus 1. So that's a 0 of that factor. So if I let x equal 1, let's see what happens. So on the left-hand side, I'm going to have 1 cubed minus 8 equals, now if I substitute a 1 in here, it's going to go to 0, 0 here, 0 here, 0 here. The only one that survives is ex squared. So that's going to be e times 1 squared, which means negative 7 is equal to e. So e is negative 7. Okay, now at this point, there's nothing else I can substitute in to make things cancel out or equal 0. So I'm going to put these values back in to, let me box it so you can see which one we're going to reference. We're going to substitute these values of b and e in here, and then I'll show you what to do. Okay, so I have now x cubed minus 8 equals ax times x minus 1 cubed plus 8 times x minus 1 cubed, since I know that's what b equals, plus cx squared times x minus 1 squared plus dx squared times x minus 1 minus 7x squared, since we know e is negative 7 now. Okay, what do you do from here? Well, whatever coefficients you found, you're going to take those terms and then move them to the left-hand side, and then regroup and see if you can factor so you can cancel out some more stuff. This is typically the way it has to go. So let me move that all over now. I'm going to have x cubed minus 8, and then now I have minus 8 times x minus 1 cubed plus 7x squared, okay, those guys moved over, equals ax times x minus 1 cubed plus cx squared times x minus 1 squared plus dx squared times x minus 1. Okay, now we got to multiply this thing out. So we have here x cubed minus 8 times, well, x minus 1 cubed, you could write it out 3 times, or if you remember from Pascal's triangle, it's x cubed minus 3x squared plus 3x minus 1 plus 7x squared equals that whole mess. And then I'm just going to focus on cleaning up right here for a little bit. Then we're going to have x cubed minus 8 minus 8x cubed. I'm going to distribute now. okay, minus 8x cubed plus 24x squared minus 24x plus 8 plus 7x squared is that whole mess. And then, let's see, let's combine our like terms. I think we're in a good place. So we've got an x cubed and we've got a negative x cubed. So that means I have a negative 7x cubed. Okay, who's next? Who's next? X squared. So we've got a 24x squared and a 7x squared. So that's a 31x squared. And then I've just got the one lonesome negative 24x. Okay. And then look at that. Oh my goodness, the 8's cancel out. Lovely. And this equals, now we're going to write the whole mess out, ax times x minus 1 cubed plus cx squared times x minus 1 squared plus dx squared times x minus 1. Okay, now our job is to try to factor the left-hand side so that we can cancel or reduce out one of the factors in the whole equation. I can take out a negative x, and then I'm left with 7x squared minus 31x plus 24 equals this stuff. Okay. Now, in order for this to get anywhere, one of the factors here has to match one of the factors on the right-hand side. So I'm suspecting one of the factors is going to be x minus 1. And that actually works out when you sit there and factor. I'm going to have negative x. If one of the factors is x minus 1, then the other factor has to be 7x minus 24. And then you can check quickly. That would give me 7x squared. That's negative 24x minus another 7x. There's my negative 31x. And then there's plus 24. And it has to work out that one of the factors here is going to cancel with the factor over here. Otherwise, you're going to be totally stuck, okay? So you can always kind of guess and play with that. Let's see now what is going to result. Oh, let me paste this guy so I don't have to keep rewriting it. Here we go. Okay, so here's the fun part, because look, we can cancel so much stuff. So I can take out actually an x and an x minus 1. So let me go ahead and do that. I'll erase this. And I'm going to take out an x from everybody and an x minus 1. So if I take out an x and an x minus 1, then I have a times x minus 1 squared plus cx times x minus 1 plus dx. That's it. Because we took out an x and an x minus 1. Okay, looks good. So we can start canceling now. So this x cancels out, this x minus 1 cancels out, and then now remember you have negative 7x minus 24 equals a times x minus 1 squared plus cx times x minus 1 plus dx. Okay, we're almost there. You basically start the process over again, all right? So you're gonna let x equals 0. And if we do that, then we're gonna have, well, this is gonna be negative 0 minus 24 equals a times 0 minus 1 squared plus 0 plus 0. So this is positive 24 equals a. So I've got that value. And then the other thing is I would let x equal 1. And if I did that, well, let's see, then I'd have negative 7 minus 24 equals, then this would be 0 plus d. So then 7 minus 24, that's going to give me, I lost where I was. That's going to be negative 17 and then negative again. So that means d is positive 17. Okay. All right. So I've got a and d. We got to do this one more time, guys. I know. So we have negative 7x, let me distribute this, plus 24 equals, I know a is 24 now, times x minus 1 squared, plus cx times x minus 1, that's the one I still don't know, plus 17x. Okay, so these guys get moved to the left-hand side one more time. So I have negative 7x plus 24 minus 24. I'm going to multiply out x minus 1 squared. So it's x squared minus 2x plus 1 minus 17x equals cx times x minus 1. So here we have negative 7x plus 24 minus 24x squared plus 48x minus 24 minus 17x equals cx times x minus 1. And then let's see here, what's going to cancel out so much stuff? This is fabulous. So the 24 is gone. Then I have a negative 7x and a negative 17x, and then here is the only x squared. So negative 24x squared. I have, this is going to give me negative 24x, but then I have plus 48x. So that's plus 24x. And this equals cx times x minus 1. And then let's factor out the GCF on the left-hand side. I can take out a negative 24x. And then I have x minus 1 left. And this equals cx times x minus 1. So that means I can cancel the x. I can cancel the x minus 1. And I know now c is equal to negative 24. You guys, we made it. We made it. So now we're going to put our answer all together. Okay. We have x cubed minus 8 over x squared times x minus 1 cubed equals, and then we had a over x, so 24 over x, plus b was 8 over x squared, plus c is negative 24 over x minus 1, plus d was 17 over x minus 1 squared, plus e was negative 7 over x minus 1 cubed. These are definitely the hardest kind of partial fraction decomposition, in my opinion, when you have lots of repeated linear factors. So just know we basically got through the worst and trickiest example you'll probably come across. The rest are going to be a lot easier compared to this, but you have to know this technique of after you've solved for a couple coefficients and you have nothing else to plug in to make zeros, right, to zero out the factors, then you have to substitute those values back in, move them over to the left-hand side, distribute, refactor, cancel, and start all over again, okay? You have to really keep track of what's going on because one little mistake will just make everything spiral out of control. So if you're that person who always forgets the negative or whatever, it's just time to stop doing that, okay? Just focus, you can do it. Okay, let's lighten the mood. Case 3. Q contains a non-repeated irreducible quadratic factor. So what that means is we have a factor that is quadratic, but it's prime, basically. You can't break it down or factor it any further. And in that case, what you would need to do in the numerator, instead of just having an a or a b, you would have to have ax plus b. You'd have to have a linear expression. So I'm going to show you how to set that up. And here we're going to find the partial fraction decomposition for 3x minus 5 over x cubed minus 1. So first things first, I'm going to factor the denominator. So we have 3x minus 5 over, now x cubed minus 1, that's a difference of cubes, so that's going to factor into x minus 1 times x squared plus x plus 1. That you just need to memorize. And then for the factor x minus 1, that's linear, so I can just have a over x minus 1. But x squared plus x plus 1, this is prime, right? It cannot be broken down any further, which means it's an irreducible quadratic. Okay, that's the same thing. So x squared plus x plus 1, since I have a squared term in the denominator, I need a linear expression in the numerator, so I need bx plus c up here. Okay? From here, the rest of the process is the same. So I'm going to multiply through by the LCD, and don't worry, this one's not going to take forever like the last one. So I'm going to multiply by x minus 1 times x squared plus x plus 1. And then now we have here on the left-hand side 3x minus 5 equals a times x squared plus x plus 1 plus bx plus c times x minus 1. Okay? Now, I'm going to box this. You could start off by letting x equal something that would cancel out a good chunk of the equation. So we could let x equal 1 if you want to get started. So then I'd have 3 minus 5 equals a times 1 plus 1 plus 1 plus, and then this whole thing's just going to be 0 if x is 1. So then I have negative 2 equals 3a. So a is negative 2/3. Okay? But after this point, you're pretty much stuck because remember, since x squared plus x plus 1 is prime, you can't substitute something in, at least not a real number, that's going to make it equal 0. And so in that case, you're going to have to do method 2 that I showed you at the first example where you distribute everything and group the coefficients according to the terms. So here, I'll show you what I mean. So since we are stuck, now I have 3x minus 5 equals, I'm going to distribute, and this one's not so bad to distribute. It's not like the last one. ax squared plus ax plus a plus, and then you have to FOIL out that next part, the bx plus c times x minus 1. So it's going to be bx squared minus bx plus cx minus c. Okay, so let's make an equation for all the x squared terms. Well, I don't see an x squared on the left. Basically, it's 0x squared. So 0 must equal a plus b. Now let's make an equation for the linear terms, okay? So 3 must equal a minus b plus c. So 3 equals a minus b plus c. And then what about the constant term? So negative 5 equals a minus c. Now we do already know that a is negative 2/3, so that's helpful actually, because if a is negative 2/3, then that means b has to be positive 2/3 since a plus b is 0. And if a is negative 2/3, I can just substitute that into this last equation to get c. So negative 5 equals negative 2/3 minus c. If I add 2/3 over, that's negative 15/3 plus 2/3 equals negative c. So negative 15/3 plus 2/3, that's negative 13/3. So c equals positive 13/3, and I'm done. Okay, so in this case, we used a combination of the methods in order to solve the system because we had that irreducible quadratic factor. And then we're going to write out our final answer nicely right now, don't worry. So we have 3x minus 5 over x cubed minus 1 equals, and then you just leave a in the numerator like this, negative 2/3 over x minus 1. I know you've been scolded not to have a fraction within a fraction, but just leave it this way, and when you're in calculus, you'll see why. It's not a problem. When you're doing partial fraction decomposition, just leave the coefficients as they are. Plus 2/3 x, since that was b, bx plus c is 13/3. Over x squared plus x plus 1. Okay, see, that one wasn't so bad. After you survive that second example, everything else is easy breezy. Okay, one last case. It's pretty fun too. So case 4 is q, the denominator, contains a repeated irreducible quadratic factor. So what that means is you have some quadratic factor, but it's raised to some exponent greater than or equal to 2, okay? And basically you follow the process that you did for repeated linear factors. It's just in the numerator now you would need a linear expression, and you would cycle through your coefficients. I don't use these subscripts, it gets too messy. We have plenty of letters in the alphabet. Okay, so here we go. Find the partial fraction decomposition of x cubed plus x squared over x squared plus 4 squared. So see, this x squared plus 4 can't be factored any further, and it's repeated because it's raised to the second power. So when we write out our setup, we have x cubed plus x squared over x squared plus 4 squared. So I'm first going to list out x squared plus 4 to the first power, and then I'm going to have x squared plus 4 to the second power, okay? And then in the numerator, since I have a quadratic factor in the denominator, I have to have a linear expression, ax plus b and cx plus d, okay? And then the next step, same as before, I'm going to multiply through by the LCD. So that's going to be x squared plus 4 squared. And then now let's see what we're going to be left with. So on the left-hand side, just x cubed plus x squared equals, and then I'm going to have ax plus b times just one factor of x squared plus 4 plus cx plus d. Now notice here we only can use the second method of grouping the coefficients because nothing will make x squared plus 4 equal 0. All right. So from here, I'm just going to multiply everything out. So we have x cubed plus x squared equals, distributing here, and here we have ax cubed plus 4ax plus bx squared plus 4b plus cx plus d. Okay, now let's start with the cubed terms. So I have x cubed, so 1 is equal to a. So I already know right now, 1 equals a. What about x squared? So x squared, that's a 1, and there's a bx squared, that's it. So I know b is also equal to 1. See how easy breezy this is? Okay, what about the x to the first power? There's no x's to the first on the left-hand side. And then I have 4ax plus c. So 4ax plus c must be 0. And then what about the constants? There's no constants on the left, and that must equal 4b plus d. But I already know that a is 1, right? So that means -4 is equal to c. And I also already know that b is 1, so that means -4 is equal to d. So we're done. We didn't have like a crazy system of equations to solve. And now I'm ready to put it all together. So I have x cubed plus x squared over x squared plus 4 squared equals x plus 1 over x squared plus 4 to the first, right? That was a plus b, ax plus b. And then I have plus cx plus d. So plus -4x minus 4 over x squared plus 4 squared. And then when you get to your calculus class, doing this partial fraction decomposition is just going to be the first part of the problem. And then after that, you'll be able to proceed and do all the beautiful calculus necessary. So make sure you master this technique. It's really important. And feel free to subscribe and comment down below.